This is Suresh, Faculty of Mathematics, working in Trinity Junior College. Students, we are going to discuss the yesterday's topic, complex numbers. We are going to discuss the yesterday's topic, complex numbers. In that we'll do some problems. Already yesterday we discussed the problems based on conjugate of the complex number and simplification and express the complex number in the form of a plus ib and the square root of the complex number. Like that we'll do some more models on complex numbers. See, here we have one problem. Show that 2 minus I by 1 minus 2i whole square and minus 2 minus 11i by 25 are conjugate to each other, See, these two complex numbers he was asking to prove they are conjugate to each other. See, for this second complex number we don't have any problem. Why? Because directly it is in complex form. A plus IB. But this is not in the complex form. 2 minus I by 1 minus 2i whole square is not in the complex form. First we have to convert this one, express this one in the complex form first of all. What is a complex number form? A number which is in the form of a plus ib. A number which is in the form of a plus ib, then it is called complex number. That's why first we have to convert this one into complex form. I am assuming the given two complex with notations z1 as the first complex number 2 minus I by 1 minus 2i whole square and the second complex number z2 is equal to minus 2 minus 11i by 25. With this we don't have any problem. Why? Because it is the standard form, a minus ib, constant form is same. But here this is not in the standard form of a complex number. That's why we have to change this one into standard form of the complex number. What is the standard form of the complex number? A plus ib. That's why first expand this denominator. 2 minus I by a minus b whole square. A square plus b square. 2y whole square. Minus 2ab, a minus b whole square, regular form, general form is this. A square plus b square minus 2ab, 2 into 2i. 2 minus I by 1 square 1, 2 square I square. Nothing but minus 4 or not. 2 square I square. What is the value of I square, Nana? That is a minus 1. That's why 2 square I square. I square value minus 2 square value 4. That's why minus 4. Minus 4i. This is equivalent to 2 minus I by minus 3 minus 4i. Still it is not in the standard form. Then we should go for multiply and divide with its conjugate. Why we are going for the conjugation? In the denominator, imaginary part is there. If it is a complex number, there won't be any imaginary part in the denominator. We have to remove imaginary part from the denominator. That's why we are going for conjugation. To remove this imaginary, we have to multiply and divide with its conjugate. Minus 3 plus 4i. What is the conjugate of minus 3 minus 4i? That is minus 3 plus 4i. A plus ib conjugate is a minus ib. A minus ib conjugate is a plus ib. Minus 3 plus 4i by minus 3 plus 4i. Now the denominator is minus 3 minus 4i into minus 3 plus 4i. A minus b into a plus b. A square plus b square. A square plus b square. Now comes to the numerator multiplication. 2 into minus 3. 2 into minus 3. Minus 6. Next 2 into 4i plus 8i minus I into minus 3 plus 3i minus I into 4i minus 4i square. Okay. Then minus 6 as it is. 8i plus 3i 11i minus 4i square. Minus 4i square. What is the value of I square, Nana? I square value is minus 1. I square value is minus 1. Then minus 1 into minus 4. Then it becomes plus 4. Divided by, comes to the denominator, 3 square value is 9. 4 square value is 16. Therefore, minus 6 plus 4. Minus 2. 11i. Divided by 16 plus 9, 25. This is the complex number. Therefore, complex number Z1 is what now? Originally he was given, first complex number is 2 minus I by 1 minus 2i whole square. But after the simplification, we converted into its standard form. Then this complex number 2 minus I by 1 minus 2i whole square becomes minus 2 plus 11i by 25. Now it is the standard form or not? A plus IB. A plus IB. Constant is there in the denominator. Therefore, Z1 is this one. Find out now its conjugate. Find out its conjugate. Conjugate of Z1 is equal to what, Nana? Z1 bar. Conjugate of the complex number Z1 is Z1 bar. Therefore, Z1 bar is nothing but minus 2 plus 11i by 25 conjugate. Minus 2 plus 11i by 25. Its conjugate bar. Therefore, minus 2 bar is nothing but minus 2. If we go for conjugate, then there is no change in the real part. Now sign of the imaginary will changes. Plus 11i becomes minus 11i. A plus ib is a minus ib. A plus ib. Then it becomes a minus ib divided by 25. See what you observed. Conjugate of Z1. Already what is given? The complex number Z2 as minus 2 minus 11i by 25 or not? See, we got the same thing or not? Therefore, Z1 bar is equal to minus 2 minus 11i by 25 is Z1 bar is equivalent to Z2 or not? Z1 bar is equivalent to Z2 or not? Therefore, we can say that conjugate of this Z1. Conjugate of Z1. Therefore, Z1 we got it as minus 2 plus 11i by 25. Its conjugate what we got? Z1 bar as minus 2 minus 11i by 25. This is nothing but the given complex number Z2 minus 2 minus 11i by 25. Therefore, conjugate of Z1 is Z1 bar. That Z1 bar is equal to given complex number Z2 as it is. Therefore, we can say that the given two complex numbers Z1 and Z2 are conjugate to each other or not. Therefore, the given two complex numbers Z1 and Z2 are conjugate to each other. Conjugate to each other. Even without applying conjugate of Z1, you can go for Z2 conjugate also. Z1 is minus 2 plus 11i by 25. If you go for its conjugate Z2 bar is minus 2 plus 11i by 25. Same or not? Z2 bar is minus 2 plus 11i by 25. Z1 what we got? Minus 2 plus 11i by 25. Therefore, if you apply conjugate to Z1, then it is also equivalent to Z1. Z2 bar is equal to Z1 or Z1 bar is equal to Z2. Therefore, both are conjugate to each other. Then we'll go for the next problem. If x minus iy whole to the power of 1 by 3 is equal to a minus ib, then show that the value of x by a plus y by b is equal to 4 of a square minus b square. He gave this condition x minus iy whole to the power of 1 by 3 is equal to what, Nana? A minus ib. Then he is asking to calculate x by a plus y by b is equal to 4 of a square minus b square. Means first we should get what is x by a and what is y by b from the given condition. Comes to the solution point of view. He gave the condition x minus iy whole to the power of 1 by 3 is equal to a minus ib. Here x minus iy whole cube is there, then we can go for a minus b whole cube form. But it is not an integer, positive integer. It is a fraction, which is a rational number. Therefore, first we have to remove this 1 by 3. 1 by 3 is nothing but a cube root or not? 1 by 3 is nothing but a cube root. Therefore, to remove this cube root, cubing on both sides. Cubing on both sides. Cubing on both sides. X minus iy whole power 1 by 3 whole cube is equal to a minus ib whole cube. 3 gets cancelled. We will get x minus iy. Now the power, rational power is removed. This is equivalent to 2. Now it is in the form of what, Nana? A minus b whole cube. What is the formula of a minus b whole cube? A cube minus 3a square b, 3a square b plus 3ab square, 3ab square, a cube minus 3a square b plus 3ab square minus b cube, nothing but ib whole cube. I am writing the formula here. A minus b whole cube formula. A cube minus 3a square b plus 3ab square minus b cube. In this formula, we have replaced in place of b as ib. In this b, we are replaced with ib. That's why a cube minus 3a square b. b is nothing but what, Nana? In place of b, we have ib is there. That's why ib was replaced. Plus 3ab square. 3ab square minus b cube. Now simplify it. A cube minus 3a square b into I. Next plus 3a. This is, if you open this bracket, I square b square minus I cube b cube. ib whole cube, no. That's why it is I cube b cube. A cube minus 3a square b I square value is what, Nana? Minus 1. Then it becomes minus 3a b square. Minus 3a b square. I cube value. Since I square equal to minus 1. What is about I cube? Comes to I cube. I cube is nothing but I square into I. I square value is minus 1. Then it becomes minus I. Therefore, I cube value is minus I. Already minus is there. Minus of minus I into b cube. A cube minus 3a square bi minus 3a b square minus into minus plus I b cube. Now separate the real parts and imaginary parts. Separate the real parts and imaginary parts. A cube is the real part. Minus 3ab square is the real part. Therefore, a cube minus 3ab square. This is a real part. Now, these two are the imaginary parts. These two are the imaginary parts. Therefore, on the left side we have x minus iy form is there. X minus iy. That's why I am taking from these two minus I as common. I am expressing into the same form whatever we have on the left side. X minus iy. Therefore, from these two I am taking minus I as common. Therefore, here it is 3a square b. Here from plus I we have taken minus I common. Therefore, we will get minus b cube. Now, comparing on both sides. Now, comparing on both sides, real and imaginary parts. Comparing on both sides, real and imaginary parts. Now the real part, here it is x, on the right side the real part is a cube minus 3ab square. We get x is equal to, real part is what, Nana? A cube minus 3ab square, and imaginary part, here minus iy, this is also in the form of minus I into something. Therefore, both are in the same format or not? X minus iy, this is also x minus iy. Therefore, y is equal to imaginary part. This is 3a square b minus b cube. Okay. Now, x is equal to a cube minus 3ab square. I am taking a common. I am taking a common. Why we are taking a common? Because I want to get the value of x by a. I want to get the value of x by a. That is the reason we are taking a as common. A common, then it becomes a square minus 3b square. X is equal to. Then take a to the denominator. X by a is equal to a square minus 3b square. This is the value of x by a. Similarly, now create y by b. Now create y by b. Therefore, y is equal to, from these two, take b as common. B as common, 3a square minus b square. Therefore, if we take b to the left side denominator, y by b is equal to 3a square minus b square. Now we got the value of x by a, we got the value of y by b. We got the value of x by a and we got the value of y by b. Now go for x by a plus y by b is equal to, add these two values, a square minus 3b square plus 3a square minus b square. A square plus 3a square, that is nothing but 4a square minus 3b square minus b square, that is nothing but 4b square. From these two, if you take 4 as common, a square minus b square, that is the value of x by a plus y by b. Therefore, finally, x by a plus y by b is equal to 4 of a square minus b square. Find the real values of theta. Find the real values of theta in order that 3 plus 2i sin theta by 1 minus 2i sin theta is a real number, is purely imaginary number. See, first to try to understand the question here, he was asking to find the values of theta. Find the values of theta, for which this complex number 3 plus 2i sin theta by 1 minus 2i sin theta, when if this is a real number, if this complex number is a real number, in that case what are the values of theta he was asking. And the second question in this is, if this is a purely imaginary number, if this is purely imaginary number, then what are the values of theta he was asking. If this is a real number or imaginary number, to get real or imaginary, first of all it should be a complex number. To find a real or imaginary, first of all the complex number should be in the form of a plus ib. Is this in this format? No. If that one is in this form, a plus ib, we can say that this is a real part of the complex number z, and this is called imaginary part of the complex number z. If it is a real number, then imaginary part equal to 0. There is no imaginary part. If it is only real means there won't be ib. There won't be ib. If it is imaginary, then real part is equal to 0. There won't be a real number. There won't be a real part. Only ib will be there. Means to get a real number or a imaginary number, first of all we have to convert the given into standard form of a complex number. Standard form of the complex number. That is nothing but a plus ib form. For that, now I am considering the given complex number as let z is equal to 3 plus 2i sin theta by 1 minus 2i sin theta. I am comparing with z. I am assuming with z. That is the given complex number 3 plus 2i sin theta by 1 minus 2i sin theta. But actually it is not in the standard form, which is a plus ib. Now we have to convert this one into a plus ib form. For that, remove imaginary part from the denominator. Why it is not a complex number? Because imaginary is there in the denominator. That's why it is not a complex form. If we remove imaginary part from the denominator, then we will get a complex number. That's why remove imaginary from the denominator. 3 plus 2i sin theta divided by 1 minus 2i sin theta. To remove imaginary, then we should go for what, Nana? Conjugation. We should go for conjugation. Therefore, multiply and divide with its conjugate. What is the conjugate of 1 minus 2i sin theta? That is what? 1 plus 2i sin theta is the conjugate of 1 minus 2i sin theta. 1 plus 2i sin theta is the conjugate of 1 minus 2i sin theta. That's why we multiply and divide with the same number, 1 plus 2i sin theta. Go for multiplication. Denominator a minus b into a plus b. A square minus b square. But comes to complex numbers, a minus ib into a plus ib becomes a square plus b square. 1 square plus b square. 2 sin theta whole square. Comes to numerator. 3 into 1. 3 plus 3 into 2i sin theta. 3 2s are 6. 6i sin theta. 6i sin theta. Next, 2i sin theta into 1 plus 2i sin theta. Next, 2i sin theta into 2i sin theta plus 2 into 2, 4. I into I square. Sin theta into sin theta, sin square theta. Okay now? Now we multiplied. 3 into 1 is 3. 3 into 2, 6i sin theta, 2i sin theta into 1, 2i sin theta, 2i sin theta into 2i sin theta, 2 into 2, 4, I into I square, sin theta into sin theta, that is sin square theta. Okay, the denominator is also okay, na? A plus IB into A minus IB. A plus IB. 2 sin theta is B. A minus IB. Therefore, that is A square plus B square. Already we used that form in the previous classes. Now, 3 plus, and these two are the imaginary parts. I quotients are nothing but imaginaries. 6i sin theta plus 2i sin theta. 6i sin theta plus 2i sin theta, that is nothing but what, Nana? 8i sin theta. 8i sin theta. Next, 4 as it is. I square value is what? Minus 1. That is minus 4 sin square theta divided by 1 square is 1 plus 2 sin theta whole square, nothing but 4 sin square theta. Therefore, now this is 3 minus 4 sin square theta is the real part. 3 minus 4 sin square theta is the real part plus 8i sin theta. I into 8 sin theta, which is the imaginary part, divided by 1 plus 4 sin square theta. Now this is the simplified form of the complex number z. Again I am taking z here. 3 minus 4 sine square theta. 3 minus 4 sine square theta. 3 minus 4 sine square theta plus I into 8 sine theta. The denominator part we are going to separate for both the numerator parts. We are writing the denominator individually for both the numerator parts. The denominator is 1 plus 4 sine square theta, 1 plus 4 sine square theta. Now it is in which form, Nana? Z is equal to A plus IB. It is in the form of A plus IB. Now for this complex number, he was asking, find the real values of theta in order that this complex number, this is nothing but what now? Z is equal to, this one is the value of 3 plus 2i sin theta by 1 minus 2i sin theta is a real number. If this is a real number, then what is the value of theta? Now first case, if z is real number, if z is real number, therefore imaginary part of z is equal to 0. If z is real, z is equal to, suppose, a plus ib. If z is real, if z is real means what? There is no imaginary part. If z is real means there is no imaginary part. That is, imaginary part of z equal to 0. Suppose if z is imaginary, if z is, suppose, imaginary, if it is only imaginary means there is no real part. There is no real part means there is no a. That is, real part of z is 0. That's what we have to remember. If z is a real complex number, there is no imaginary part. Means imaginary part of z becomes 0. There is no ib. If z is imaginary, there is no real part. There is no real part. That is nothing but real part of z is 0. Therefore, if z is a real number, in this case, he was asking the value of theta. Therefore, imaginary part of z equal to 0. What is imaginary part? 8 sine theta by 1 plus 4 sine square theta is equal to 0. Imaginary part of this complex number is, this is the imaginary part, this is a real part. If z is a real number, therefore imaginary part equal to 0. That's why 8 sine theta by 1 plus 4 sine square theta equal to 0. Cross multiplication, 8 sine theta equal to 0, which implies sine theta equal to 0. Therefore, he was asking the real values of theta. Therefore, sine theta equal to 0. What is the general solution? From first year trigonometric equations. From first year trigonometric equations, general solution. General solution. General solution of theta. If sine theta equal to 0, then the general solution of theta is theta equal to n pi, where what are the values of n, Nana? N belongs to z. This is, if z is real, then the values of theta are n pi. Now, second part is what? Find the real values of theta if this complex number is purely imaginary. Purely imaginary. What we are saying, if z is purely imaginary, then real part of z is equal to 0. If z is purely imaginary number, purely imaginary number, therefore real part, RE of z, real part of z should become 0. What is the real part of this z? This is the real part of the complex number. This is the real part of the complex number. Okay now? Real part is 3 minus 4 sine square theta by 3 minus 4 sine square theta by 1 plus 4 sine square theta is equal to 0. Cross multiplication. 3 minus 4 sine square theta equal to 0. Why? Because 0 into something is 0. Therefore, what we got? 3 minus 4 sine square theta equal to 0. It becomes 3 is equal to 4 sine square theta. We are taking minus 4 sine square theta to right side. Therefore, 3 is equal to what it becomes? 4 sine square theta. Therefore, sine square theta is equal to 3 by 4. Can I write this 3 by 4 as root 3 by 2 whole square? Is there any change in its original value? No. Why? Because root 3 whole square is 3 and 2 square is 4. Why we are writing root 3 by 2 whole square only? Why don't we write sin theta is equal to 3 by 4 square root? Both are equal only. But I am expressing according to trigonometric equations and general solution. I want to express this one as the left side part is in the form of sin square theta. That's why right side also I want to express it in the form of square. Sin square theta is equal to sin square alpha form. Sin square theta is equal to root 3 by 2 is nothing but sine which angle? Sine root 3 by 2 is sine 60 degrees or not? Sine 60 degrees means pi by 3. Sine square pi by 3. Sine square theta equal to sine square pi by 3. Since it is in the form of sine square theta equal to sine square alpha. Therefore, general solution of theta is what, Nana? N pi plus or minus n pi plus or minus alpha, where n belongs to z. Therefore, sin square, now it is in the form of sin square theta equal to sin square alpha or not? Sin square theta equal to sin square alpha. Therefore, general solution of theta is equal to n pi plus or minus. In place of alpha, what we have in the formula? In place of alpha, here we have pi by 3 is pi by 3, where n belongs to z. This is the solution. In case if z is a real number, then theta value is n pi. If z is a purely imaginary number, then theta value is n pi plus or minus pi by 3, where n belongs to z. See one more problem. Find the least positive integer n. Find the least positive integer n, which is satisfying the condition 1 plus I by 1 minus I whole to the power of n is equal to 1. See, he was not asking, generally we will think it is equivalent to 1 means show that this is equivalent to 1. But that is a wrong observation. Here he was asking the least positive integer n which is satisfying this condition. Means 1 plus I by 1 minus I whole power n is equal to 1 when it is possible for what value of n? The value of 1 plus I by 1 minus I whole to the power of something becomes 1. Means we have to calculate the value of n which is least positive. The value of n which is least, not greatest. To find this least value, first of all, it should be in the form of complex number. 1 plus I by 1 minus I should be in the complex number form first of all. It nothing but what? A plus IB form. Here it is not in the A plus IB form. Here we have denominator is also containing an imaginary part. We have to remove that. For that, first you express 1 plus I by 1 minus I in the standard form of a complex number. Take 1 plus I by 1 minus I. 1 plus I by 1 minus I. So solution. First simplify this one. Get into its simplified form. Get into its simplified form, which is the standard form of the complex number. Nothing but a plus ib. 1 plus I by 1 minus I. To remove I means imaginary from the denominator, we should go for always conjugation. Multiply and divide with its conjugate. 1 minus I conjugate is 1 plus I. 1 plus I. Therefore, numerator is 1 plus I whole square divided by, now denominator is a minus I into a plus I, means a minus ib into a plus ib. A square plus b square. Why? Because already we discussed a plus ib into a minus ib is equal to what, Nana? A square plus b square. Actually, a plus ib into a minus ib, it becomes a square minus b square originally. Minus ib whole square. A square minus I square b square. A square. I square value is what? Minus 1. Minus of minus. Therefore, it becomes a square plus b square. That's why a plus ib into a minus ib, we will write always a square plus b square. That's why here a square is 1 square. B square is also I into 1. No. That's why b square is also 1. Numerator, expand the formula. Numerator a square plus b square I square plus 2ab 2i divided by 1 square plus 1 square. 1 square is 1. I square value is minus 1 plus 2i divided by 2. 1 1 cancel. 2i by 2. 2 also cancel. Therefore, what we got? The value of 1 plus I by 1 minus I, we got it as I. Now we got the value of 1 plus I by 1 minus I as I. Now go for, now 1 plus I by 1 minus I whole to the power of n. Nothing but I to the power of n. He was asking this power n, I power n is equal to 1 when it is possible. For what value of n, this I power n becomes 1. For what value of n, this I power n becomes 1, he was asking. If suppose least positive integer, if suppose I am taking n is equal to 1, which is a positive integer or not. If I take n equal to 1, I power 1, the value is I, which is not equal to 1. If you go for n is equal to 2, I square value we know very well, that is minus 1. Is it is equivalent to 1? No. If you take n is equal to 3, I cube value is nothing but I square into I square value minus 1. Therefore, it is what, Nana? Minus I. Even this is also not equivalent to 1. Next, n is equal to 4. I to the power of 4. I to the power of 4 is nothing but I square whole square minus 1 whole square, which is equivalent to 1. Therefore, if n is equivalent to 4, 1 plus I by 1 minus I whole to the power of n value becomes 1. So, why don't we go for n is equal to 8? You may get the doubt. If you take n is equal to 8, then what it becomes? I to the power of 8. I to the power of 8 is nothing but I to the power of 4 whole square. This is also 1. But when n is equal to 4, the value is 1. When n is equal to 8, the value is 1. Similarly, when n is equal to 12 also, the value is 1. But in 4, 8, 12, which is the least positive integer? That is 4. Therefore, for n is equal to 4, 1 plus I by 1 minus I whole to the power of n value becomes 1. That's why we don't take n is equal to 8, n is equal to 4 and everything. Therefore, we can write for n is equal to 4, the value of 1 plus I by 1 minus I whole to the power of n should becomes 1. Therefore, n is equal to 4 is the required least positive integer of n. Find the real values of x and y if x minus 1 by 3 plus I plus y minus 1 by 3 minus I is equal to I. By using this condition, he was asking the values of x and y which are involved in this condition. Solution. First, express this one, the left side part, in the form of a plus ib to get the equations in terms of x and y. X minus 1 by 3 plus I plus y minus 1 by 3 minus I is equal to I. Go for LCM. 3 plus I into 3 minus I. Now it becomes x minus 1 into 3 minus I plus y minus 1 into 3 plus I is equal to what, Nana? I. Now the denominator part is a plus ab into a minus ib. 3 square plus 1 square, that is a square plus b square. A square plus b square. Now multiplication. 3 into x minus 1, 3 into x minus 1 minus I into x minus 1 sorry, plus again 3 into y minus 1 plus I of y minus 1, open the bracket, 3 into y minus 1 I of y minus 1 is equal to I. Now 3x minus 3 plus real parts, these are the real parts other than I coefficients. 3y minus 3 real parts, okay, plus I of imaginary parts, these two are the imaginaries, I coefficients. Y minus 1, this one is positive, that's why I am writing first. Then this is minus of x minus 1 minus x plus 1. Minus I is there, but actually we have taken plus I as common, that's why minus into x minus x minus into minus 1, then it becomes plus 1 divided by 3 square is 9, 1 square is 1 is equal to I. 3x plus 3y minus 6 is the real part. Here 1 cancel. Now this is plus I of y minus x. Now go for cross multiplication. 9 plus 1 is 10, 10i. Now the left side part we can write it as 0 plus I into 10. It is expressed in the form of a plus ib. 3x plus 3y minus 6 is the real part. I into y minus x is the imaginary part. Comparing on both sides. Comparing on both sides, real and imaginary parts. Imaginary parts. What will get the real part is right side 0, left side is 3x plus 3y minus 6. 3x plus 3y minus 6 equal to 0. And the imaginary part is right side 10 I coefficient. On the left side the imaginary part is y minus x. Y minus x is equal to 10. Therefore, we can write this one as, take it into right side, x minus y plus 10 is equal to 0. This is, if we take 3 as common, x plus y minus 2 equal to 0, 3 is cancel, x plus y minus 2 equal to 0. This is equation 1 and this is equation 2. Solving these two equations, equation 1 plus 2. To solve the equations we have different methods are there, that is elimination method is there, and we can go for the methods of cross multipliers, different methods are there. Here we are going with addition, x plus y minus 2 equal to 0, x minus y plus 10 equal to 0, y cancel, 2x plus 8 equal to 0, 2x equal to minus 4, then x is equal to 2x equal to minus 8, then x is equal to minus 4. Substitute the value of x in any of these two equations, either equation 1 or equation 2, will get the value of y. Substitute x equal to minus 4 in 1. Equation 1 implies minus 4 plus y minus 2 equal to 0, minus 2 minus 4 minus 6, y is equal to 6. Thank you.